Okay, today you are going to be using trig ratios again. To solve triangles. Except for today, you're going to get the information a little bit different than you have the last couple days. Instead of them just giving you a picture of a triangle with some side lengths or some angle measures on it, you're going to get the information for the triangle. In example 4, you're going to get it via the coordinates of each vertex. So if you look at example 4 on page 354, yeah, page 554. It says the coordinates of the vertices of triangle JKL are J is at -1, 2. K is at -1, -3. And L is at 3, -3. Find the side lengths to the nearest hundredth and the angle measures to the nearest degree. So what they're really saying is to solve the triangle. So the first thing I would do would be to graph it. So if you sketch a coordinate plane, and your point J is at -1, 2. K is at -1, -3. And L is at 3, -3. So there's the 3 vertices of this triangle, and you can connect them. And as you can see, K is the 90-degree angle. Now, your vertical side and your horizontal side, you could find those lengths from the coordinates. All right, your vertical side goes from +2 to -3. So wouldn't that be 5 units? Your horizontal side goes from -1 to +3. So that leg would be 4. So the missing information to solve the triangle, you would need the measure of angle L, the measure of angle J, and you would need the length of side JL. So I'm going to find this angle L first. And remember your acronym, SOHCAHTOA. And in relation to angle L, the sides that are given are opposite and adjacent. So that's a tangent ratio. So the measure of angle L is going to be equal to tan -1 times opposite over adjacent, which is 5/4. So in the black calculator, it's 5 divided by 4 equals, and then second tan equals, and we're rounding those to the nearest degree, so it's 51 degrees. So if angle L is 51 degrees, 90 minus 51 will give you angle J. And is it 39 degrees? So there's the first 2 parts of the question. L is equal to 51 degrees. J is equal to 39 degrees. And now you need side JL. So I'm going to use the 51 degree angle again. I'm going to use the opposite side to find the hypotenuse. So opposite and hypotenuse is sine. So the sine of 51 is equal to the opposite side, which is 5, over the hypotenuse, which we're calling JL. So you can solve for JL by, you can start by multiplying JL by both sides, and that gets it out of the denominator. So those would cancel. And then you could isolate JL by dividing both sides by sine 51. These would cancel. And JL would be equal to 5 divided by 51 sine equals 6.43. You're rounding side lengths to the nearest hundredth, so that side length would be 6.43. Now, you've been doing all of this for 2 days, haven't you?
Yeah.
The only thing different is that you've got to graph the triangle first so that you could get those side lengths.
That makes, yeah.
Okay? So they're just incorporating some coordinate plane work in there.
Wait, so what you did to get the 5 is like, you did like the 2, and then you had -3, so did you just add them?
I asked myself, how far is it from +2 to -3? It's 5 units. And then how far is it here from -1 to +3? And that's 4 units.
Alright.
The second type of problem in your assignment today is going to look like example 5 on 554. A lot of words in there. San Francisco's Lombard Street is known as one of the crookedest streets in the world. The road's 8 switchbacks were built in the 20s to make steep hill passable by cars. Here's what matters. If the hill has a percent grade of 84%, percent grade, 84%. What angle does the hill make with a horizontal? So the question is, what angle does the hill make with a horizontal line? Grade in this question relates to incline or decline, which for you means slope. Okay? Incline or decline, grade, pitch of a roof. Usually when they're talking about roads or driveways or land, they call it grade. So in this case, this 84% grade, 84% is equal to 84 over 100. And if you're talking about incline or decline, you're also talking about slope. And slope is also rise over run. So here's how it relates to right triangles and sine, cosine, and tangent. If you draw a right triangle, and you make the vertical side the rise and the horizontal side the run, and you give the rise a value of 84 and the run a value of 100, doesn't that represent your 84% grade?
Oh.
So the hypotenuse represents the street, doesn't it? Or the hill.
So in this we'll have to find the hypotenuse.
In this case, the question was, what angle does the hill make with the horizontal line? Hill and horizontal line. Well, you don't need this angle, do you? Hill and the horizontal. So here's the hill.
So first you have to
Here's the horizontal.
First
you would have to do tangent, like, and then just kind of like.
You're looking for an angle measure, right?
Yeah.
So Toa,
That's funny.
you're dealing with opposite and adjacent. And you're trying to find an angle measure, so you're dealing with tan -1, right? So the measure of this angle, the measure of the angle that you're looking for is equal to tan -1 opposite over adjacent, or times opposite, which is 84, over adjacent, which is 100. And then it's a calculator problem. 84 divided by 100, and then second tan equals
40.
40 degrees.
So basically you just turn it into a triangle and solve it.
Exactly. Yeah, but you don't have to, in this case, you do turn it into a triangle and you do solve it, but you don't have to solve the whole triangle.
Yeah, but like, so like, yeah.
If they asked you, how far up the hill does the car have to go or something like that, then you would find the hypotenuse.
Okay.
So to answer the question, what angle does the hill make with a horizontal line? It's 40 degrees. This is 40 degrees. Pretty steep hill.
That's pretty steep.
Pretty steep hill. Isn't it? Really steep hill. Any questions? Now, your assignment for today is page 555, 19, and then on 556, number 20. And that's it. It's one of the graphing problems and solve the triangle, and then it's just one of the word problems to practice. Now, from here moving forward, when you check Edline for homework, I've told you to do this in the past. I'm telling you again because I care about you.
You're gonna close the meetings.
When you check Edline for homework, make sure you have your assignment finished and in front of you, and make sure you have your notes in front of you. Understood?
Yes.
I'm not trying to scare you.
You're scaring me.
I'm trying to tell you to have your notes in front of you when you check Edline for homework and have your assignment completed. Okay? Because you're going to start seeing questions from the notes. Specific questions from the notes. Something like one of your homework questions being, in your notes today, in example 4, the distance from J to L was.
Oh.
So if you took notes, like you're supposed to, it would be very simple for you.
Haven't we already been doing that?
No, we haven't been doing it in that sense. It's been mostly from the homework problems. But I've got students in other classes that aren't taking notes at all. They're playing on their phone the whole period. So if you've been taking your notes all along and you've got them with you and they're organized, it's just going to, for you, it's going to be easier. But it's a way for me to hold people accountable for taking their notes.
Yeah.
So that's the explanation if you needed one.